Welcome again. This is to the last session of the conference and to the Hahn lecture. I am delighted to introduce to you Nicola Fuchs-Schündeln to give this lecture on the long-term distribution and welfare effects of COVID-19 school closures. It's a real pleasure to have her here with us, or at least virtually here with us. She is Professor of Macroeconomics and Development at Goethe University in Frankfurt. And prior to joining Goethe in 2009, she was assistant prof at Harvard University, and she got her PhD from Yale in 2004. She is the current chair of the Review of Economic Studies, and she's an elected fellow of the Econometric Society. In 2018, she received the Gottfried Wilhelm Leibniz Prize of the German Scientific Foundation, which is the highest scientific award in Germany. She also received a prize in 2016 of the German Economic Association. She's also been very successful in ERC competitions. She had a Consolidator Award in 2018 and a starting grant in 2020. She's also a member of the Scientific Advisory Board of the German Federal Ministry of Finance and the Franco-German Council of Economic Experts. She's also served as one of the experts on the Macron Commission, and she holds many affiliations. She's widely published in economics journals, including the AER, the Review of Economic Studies, the QJE, and others, and also, which is really nice to see for an economist, in Science, which is just fantastic. So I don't want to take up any more of Nicola's time. So over to you, Nicola, and I very much look forward to your talk.
Thanks a lot, Carol, for the nice introduction, the very kind word. And thanks a lot for giving me the chance to give the Hahn lecture at this year's annual conference of the Royal Economic Society. It's a real pleasure and honor. So I'm going to talk about the long-term distributional and welfare effects of the COVID-19 school closures. And this is joint work with Dirk Krüger, who is at the University of Pennsylvania, as well as Alexander Ludwig and Irina Popova, who, like myself, are from Goethe University, Frankfurt. So I think the motivation of this paper is fairly straightforward. As part of the policy reaction to the outbreak of the corona crisis at the start of 2020, almost all governments worldwide closed not only businesses, but also schools. And while the business closures were immediately discussed controversially in both the public debate and also in the media, initially there was much less discussion about the school closures. And one likely reason for that is that the cost of closing businesses, they arise immediately, so they are very visible to everyone, while the costs of closing schools, they only arise in the long term. And here is where our paper steps in. We want to provide an estimate of the long-run effects of the COVID-19 school closures on the affected children. And we're going to first analyze how, on aggregate, human capital, earnings, and welfare of the affected children evolved due to the school closures. And secondly, we are also interested in distributional effects. So how do children from different parental backgrounds fare in this crisis? So essentially what we are asking is, does this very transitory shock of school closures have any persistent long-term effects on the children? So this map here comes from the UNESCO, and it shows you the total duration of school closures from the start of 2020 up to basically today. So it goes up to the end of March. And here you can see that almost all countries worldwide closed their schools at least for some weeks. So for the US, the country we are focusing on, the UNESCO estimates that on average schools were closed 47 weeks until the end of March. And for the UK, where many of you are now located, the UNESCO estimates that school closures lasted 27 weeks up to today. So of course, these are rough estimates. So even within a country, there's large regional variation in the length of school closures. So different school districts or states closed schools for different amounts of time. And there is also a lot of cross-sectional difference by school type or even by grade level within the same school. So how do we go about analyzing the long-term effects of the school closures? since we don't obviously have data on this yet, we're going to build a structural model, and in this model then model the school closures. So specifically, we built a 2 generations partial equilibrium household model. So we model the current parent generation and the current children generation, and then we follow them through their life cycle until the end of their life. And the most crucial input of this model is the human capital accumulation process that happens during childhood. So while kids are young and are in school, they accumulate human capital, and they do that by receiving 2 inputs. The first input is governmental investment into the human capital that comes through schooling. And the second important input is parental investment into the children. And parents invest into their children by investing both money and time. So when these children turn adult, they take higher education decisions. So specifically, they decide whether to drop out of school and start working, or whether to continue and graduate from high school, or whether to even attend college. So we built this model and we calibrated it to the US economy, relying on data from before the COVID crisis. And now once we have this model, we can analyze the consequences of the COVID-19 crisis in 2 experiments. The first and the most important one is the school closure. So we model that by modeling an exogenous reduction of the governmental schooling input. And in the second experiment, we add to the school closures the recession, which leads to an exogenous reduction of parental incomes. So today, in the interest of time, most of the results that I will show you will focus on the first experiment, where we only take the school closures into account. And very importantly, we allow for endogenous responses by both the parents and the children to the school closures. So parents, noting that the government invests less in their children now, can increase their investments, and children will adjust their higher education decisions. So let me give you a quick preview of our main findings. What we find is that 6 months of school closures result in average lifetime earnings losses of 1% for the affected cohorts. So the children who are now in school, they will, for every day of their work, every year of their working life, receive 1% less income than they would have had in the absence of the school closures. So if you discount that to today and you sum it up over all the children currently affected by the school closures, this is equivalent to 1.4% of the US pre-crisis GDP. So this just shows that the losses from the school closures, they really are of an economically significant magnitude. And taking the perspective of the children again, the earnings losses translate into welfare losses of minus 0.55% in terms of the consumption equivalence variation. So that means the children would be willing to give up 0.55% of their annual consumption year after year until their death in order to avoid the school closures. We also find a substantial heterogeneity in these losses by parental characteristics. So children who come from disadvantaged households, they suffer significantly larger welfare losses than children who come from more privileged households. And last, we find that adding the recession leaves the welfare loss of the children almost unchanged. It increases a little bit, but really by a very tiny amount. So from the children's perspective, the COVID crisis affects their welfare negatively because of the school closures. The income recession on top of it almost doesn't matter for the children. So before I go into the model and discuss the results in more detail, I want to give you a quick overview of the literature on school closures. So there is first an empirical literature that looks at variation in schooling time and how that affects the outcomes for children. And most of these papers analyze relatively short variations in schooling times. For example, variation caused by different amounts of snow days per year. And most of the papers also look at relatively short or medium-term outcomes of children, so mostly test scores. So I want to stress one paper here that looks at an episode that is somewhat similar to the COVID school closures, namely a paper by Hahn and Willen. So Hahn and Willen document that on average, elementary school children in Argentina suffer from 6 months of teacher strikes. And these 6 months of teacher strikes are associated with long-term earnings losses for the children of 2 to 3%. So these are really significant and large earnings losses. There is also an empirical literature already on the COVID-19 induced school closures, and obviously this literature has to look at relatively short-term outcomes and cannot look at long-term outcomes yet. Here I also want to stress one paper, which is by Engel and co-authors. So they have data from the Netherlands, and the nice feature about the Netherlands is that they test their children regularly in both February and June. And the first wave of school closures in the Netherlands happened exactly in between, so between March and May 2020. So what they can do is analyze how did the test scores evolve in 2020 when schools were closed for 8 weeks, and compare that to the usual test score and how they evolved in the previous years. And what they find is that these 8 weeks of school closures led to an average learning loss of 1/5 of the school year, despite the fact that the Netherlands implemented substantial online teaching fairly quickly. So 1/5 of a school year is equivalent to 8 weeks. So they find that despite online learning, on average, these 8 weeks were completely lost for the children. And on top of that, they also find a large socioeconomic gradient. So we built a structural model, and in that sense, our paper fits into the structural literature on schooling. So first, I want to stress here the literature that developed the human capital production function that we are using, and that points out the importance of early childhood education. So these are specifically the papers by Cunha, Heckman, Schenach, and others. And this literature also stresses the importance of public education for inequality, intergenerational mobility, and welfare. Again, there are very few papers so far that build structural models to analyze the COVID-19 school closures. One paper is the one by Agostinelli and his co-authors. They zoom in on high school students and find that online teaching, but even more importantly, the change in peers lead to learning losses for high school students. So here's what I'm planning to do in the remainder of my talk. So first, I will describe broadly how our quantitative model looks like, and then I will explain the most important functional forms and calibrated parameters to you before I then get to the aggregate results and to the distributional effects of the school closures. So rather than giving you the full model with the equations, I decided to give the timeline of the life cycle of parents and the life cycle of children, and will tell you what are the most important decisions that both generations take. So I start out with the life cycle of the parents. So we model parents from age JF onwards. So this is the fertility age. So we model parents from the age onwards when they have children. And at that point in time, we take the initial distribution of parents directly from the data, and parents can differ in their marital status M, in their education S, and in their asset level A. Then from parental age JF to parental age JF plus JA, where JA is the age at which the children turn adult, the children live with the parents. So during this time, parents have children in the household, and the parents choose how much to invest into their children in terms of monetary investment, IM, and time investment, IT. And apart from that, they face a standard consumption savings choice. So at parental age JF plus JA, the children leave the household. And in this point in time, the parents can decide to leave inter vivos transfers to their children. And these transfers can be used by the children to either pay college tuition or just to consume or to save. And from then onwards, the parental generation is not so interesting for us anymore. So parents continue working until age JR. At age JR, they retire, and then they live until the final age J. And during their entire working lives, they face a standard consumption savings decision. So what are the earnings of the parents while they are working? The parents earn a wage W, E, eta, epsilon, where E is an age and education specific wage profile. So higher educated parents have on average higher earnings. And eta is a persistent productivity shock, and epsilon is a transitory productivity shock. We model labor supply as exogenous, so there's no labor supply choice in our model, but we take the working time directly from the data, and it depends on marital status. So these are the parents, and more interesting than the parents are the children. And here I show you the life cycle of the children. So we model the children from birth onwards, so from age J0. And at birth, the children draw an initial human capital H0. And that initial human capital depends on the marital status of the parents and the education of their parents. So this captures a nature channel of connection between parents and children. Then, while the children are young, so until they turn age JA, they live with their parents. They don't make any active choices, but they accumulate human capital by receiving 3 types of inputs. First, monetary investment of the parents, and time investment of the parents, and governmental investment that comes through public schooling. So then the children arrive at adulthood at age JA with some human capital, so HJA. And at that point in time, they receive potentially inter vivos transfers of their parents. And based on their human capital and the inter vivos transfers, they then make their higher educational decisions. So they decide whether to drop out of high school and start working right away, whether to finish high school, or whether to even go on and finish college. So if the children decide to finish high school, they stay in high school until age JH. And attending high school comes with a psychological cost that depends on the own human capital of the children. While they are in high school, they will also work, but a lower amount of hours than they would if they would have dropped out. And from here onwards, they always face a consumption savings decision. If the children even continue and go to college, they stay in college until age JC. Attending college also comes with a psychological cost, which depends not only on the own human capital, but also on the education of the parents. And attending college requires paying a tuition fee. Again, they work, but lower hours than they would if they would be fully in the labor market, and they face a consumption savings decision. So at age JC, the entire generation of children will be in the labor market. So from then on, they mimic exactly the parental generation. They just work, and at some point they retire. So the earnings of the children generation also mimics the one of the parent generation, with one exception, and that is this parameter gamma. So first, let me remind you, so earnings, so we allow for an age and education specific wage profile. So children may choose to obtain higher education because this leads to higher earnings later on. They also face a persistent and a transitory productivity shock. And then their wage depends on this fixed effect gamma, which translates human capital into wages. So higher human capital pay out in the form of higher wages, independent of the educational decision. So that captures some persistent heterogeneity across individuals who have the same education level, and is an additional factor why acquiring human capital is beneficial for the children. So these are the life cycles of the parents and of the children. The most important part of the model is the human capital production function. So human capital accumulation happens only during childhood. And this is how the human capital production function looks like. So human capital next period is a function of the age of the human capital this period and of the investment into human capital. And investment is just a composite of the monetary investment, the time investment, and the governmental investment. So we model this as a multiple nest with imperfect substitutability, and I will show you the exact functional form. But here I already want to stress 2 very important properties of this human capital production function that have been shown to hold in the literature. So the first property is self-productivity of human capital. So that means the higher the human capital today, the higher will be the human capital tomorrow. So basically what it captures is that learning builds on each other. The more someone has learned, the higher will be the human capital of this person in the future. And the second important property of the human capital production function is dynamic complementarity between human capital and investment. So what that means is that the same amount of investment will pay out more in terms of higher human capital tomorrow, the higher the human capital already is today. And that also implies that the optimal investment into human capital is actually increasing in the stock of human capital that an individual already has. So this is in a nutshell the model. Now I will show you the functional forms and calibration, focusing again on the most important components. And specifically, I want to discuss the initial distribution of parents and children that we put into the model, then the human capital production function, and thirdly, how human capital translates into wages through this fixed effect gamma. So let me start out with the initial distribution. So we take the initial distribution of parents directly from the panel study of income dynamics, and parents can differ in terms of their marital status. They can be single or married. In terms of the education, so the parents themselves can be high school dropouts, high school graduates, or college graduates, and we allow for 5 different initial asset quintiles. The number of children per household is also taken directly from the data, and it depends on the marital status and the education of the parents. The human capital of the children, that is very hard to measure. So we want to have a measure of the initial human capital when children are born, and we want this to allow, this to depend on the marital status of the parents and the education of the parents. So how do we measure initial human capital of the children? Well, fortunately, the PSID has a child development supplement in which it provides test scores already of children aged 3 to 5. So we take these as the initial test scores of children at age 4. So our model has a 2-year frequency. So we model age 4, 6, 8, and so on. So anything that happens before age 4 is obviously in reality a combination of nature and nurture. In our model, we take that as exogenous. We just measure this initial human capital of the children at age 4, and then active accumulation of human capital only happens after that. So let me show you how these test scores look like at age 4. So here you see the average test scores and how they translate into a fraction of initial human capital, which is normalized to 1 in the mean by parental characteristics. And there are 2 features here that you can see very clearly. First, the average test scores of these young children is increasing in parental education. Okay, so children from higher educated parents have on average higher test scores than children from lower educated parents. That is true for both single households and married households. And secondly, conditioning on the education of the parents, we see that the average test scores of single households are lower than the one of married households. That is true for low and medium educated individuals, and it actually flips for the highly educated, where the test scores of the single parents, of the children of the single parents is slightly larger than of the children of the married parents. So we take that as exogenous, and then from starting with this initial human capital, now parents make active decision to invest in the human capital of their children. So how does this human capital accumulation process look like? It's a multiple nest with 3 layers. So this is the outermost layer. So in the outermost layer, we combine human capital and investment into human capital tomorrow. And sigma H measures the elasticity of substitution between the stock of human capital and the investment into human capital. And kappa Hj, this is the age-specific weight on human capital in this accumulation. So in the middle layer, the middle layer combines governmental investment into the human capital of the children and parental investment into total investment. So here sigma G is the elasticity of substitution between governmental and parental investment, and kappa Gj is the age-specific weight on governmental versus parental investment. And last, then the innermost layer combines monetary investment of the parents and time investment of the parents in total parental investment. Sigma M is the elasticity of substitution between money and time, and kappa Mj is the age-specific weight on monetary investment. So obviously, 2 very important sets of parameters for our model are first these 3 intertemporal elasticities, these 3 elasticities of substitution, and then the 3 age-specific weight parameters. So how do we go about calibrating them? First, we take these elasticities directly from the literature. So sigma h and sigma m are set equal to 1, and sigma g is equal to 2.43. So that comes from an estimate from a paper by Kotera and Seshadri. And this means that governmental and parental investments into human capital are substitutes, but they are far from perfect substitutes. And now these three age-specific weight parameters, we calibrate them to match the age-dependent time and monetary inputs of the parents into their children. So how do they then look like? So first here on the left graph, I show you the weight on human capital in this outermost layer that combines human capital and investment by the age of the child, starting at age 4 up to age 14. And as you can see, the weight on human capital is increasing in the age of the child. So that is quite intuitive. So the older the child is, the more important is the stock of human capital rather than the investment into human capital. So this is the weight in the innermost layer, which combines monetary and time investment into total investment of the parents. And again, the weight on monetary investment is increasing in the age of the child. This is also quite intuitive. It means that for younger children, time investment of the parents is relatively more important, while for older children, monetary investment of parents is relatively more important. Now for this middle layer, we take the weight on governmental investment as opposed to parental investment, again from the paper by Kotera and Seshadri, who estimated to be 0.68 for school-aged children. And then we allow it to be potentially different for younger children who are not yet in school, so and thus receive a different governmental investment. And in fact, we calibrated it to the value of 0.44 for children aged 4. So for the very youngest children who are not yet in school, the weight on governmental investments is a little bit lower than for the school-aged children. So last, I want to show you how this human capital translates into higher wages through this fixed effects gamma. So here we follow Abbott et al. In their paper and allow for this following functional form, where how human capital translates into a higher gamma, which corresponds to a higher wage, is allowed to be different for different education groups. So we can estimate this equation, replacing this fixed effect with a residual wage and measuring the human capital through the Armed Forces Qualification Test Score using NLSY 79 data. And here in this table, I show you this estimated parameter ρ1. And as you can see, this ability gradient is increasing in education. So we find complementarity between human capital and education. What does this mean? Well, for our higher educated individuals, for those who finish college, human capital matters more in determining their wage, controlling for that being higher because they finish college, than for less educated individuals. So these are the three most important sets of parameters. Now I want to show you a little bit the model fit, how well do we do in terms of matching the data. So first I show you the model fit analyzing parental investments by the age of the child. So on the left, you see monetary investment by the age of the child. In the data, this is the black line, and in the model, that is the blue line. So it's quite noisily measured in the data, but as you see on average, it's kind of flat by the age of the child. And that is also captured by the model. And that is in contrast to time investment, where in time investment, you see a long decreasing gradient in the data, again captured by the model. So time investment of parents is significantly decreasing in the age of the child. So we match both parental investment profiles relatively well, but these are largely targeted moments. So let me also show you one set of non-targeted moments, namely parental investments by parental education. So now on the x-axis, rather than the age of the child, you have parental education. And here what you see is that in the data, monetary investment into children is strongly increasing by parental education. So high educated parents invest significantly more into their children than low educated parents, something that we match with the model. And in time investment, you also see a gradient, but it's much more flat, and it's also flatter in the model. So the model matches these investments gradients by parental education relatively well. So now we set up this model, we calibrate it to US data from before the crisis. Now we can use it as a laboratory to analyze the long-term effects of the COVID crisis. And we do this in these two experiments, which I already mentioned. So the first and the most important one is the lockdown of schools. So in our baseline estimate, we assume 6 months school closures. So I showed you the UNESCO data, which gave 47 weeks of school closures. That is almost a year already, so significantly larger than the 6 months. But obviously, when schools were closed, there was often some substitution to online teaching. We don't know the exact extent of that, but we wanted to take a little bit of a more conservative estimate. So in our baseline results, we assume 6 months of school closures. So if we translate that into the 2-year frequency of this model, that means that governmental investment into the children is reduced by 25% for one period, and after that, it will be back to the old level. And then in the second experiment, we add to the school closures the asymmetric income shock. So the 2020 output reduction in the US was 4.6%. We assume full recovery in 2021, so we might be a little bit optimistic here when it comes to the size of the income shock. In this 2-year frequency, that translates into an income loss of 2.3% on average for the parents. Now, the data says that most of this income loss comes from a reduction in hours. So most of it comes from the fact that parents become unemployed, not that productivity drops, and we take that into account. And we also allow the income shock to be asymmetric across education groups, as we see it in unemployment rates. So the income shock is more than twice as large for parents who are high school graduates or high school dropouts than for college educated parents. So now let me get to the results. So what is the effect of the school closures on the children? So this table shows you the main results. So first, average changes in different variables for all affected children, and then changes for children who are of biological age 4, 6, 8, 10, 12, or 14 in the period when the school closures happen. But let me first focus on the average differences, and let me first focus on this upper panel. So this upper panel shows the change in percentage points in the final educational attainment of the children. And what you see here is that on average, due to the school closures, the share of high school dropout will increase by 0.85 percentage points, and the share of college graduates will decrease by minus 1.07 percentage points. So this might not sound that dramatic, but if you take it in relation to the baseline shares, that means that the number of high school dropouts will increase by 7%, and the number of college graduates will decrease by 3.2%. So the school closures lead to substantial worsening of the final higher education of the children. Why is that? Well, it comes from the fact that the children arrive at this age when they take the higher education decision with lower human capital. So on average, the human capital decreases by 1.5% due to the school closures. And now this lower human capital, together with the lower educational attainment, leads to lower earnings of the children. So on average, their gross earning will decrease by 0.95%. And I already told you, if we discount that to today, sum it up and put it in relation to the US pre-crisis GDP, this amounts to 1.4% of GDP. So it's a substantial loss of these school closures. And if you go back to the children's perspective, in terms of welfare losses, on average, the consumption equivalent variation gives a welfare loss of minus 0.55%. So what we find is that this very temporary shock of school closures, 6 months of closed schools, has long-run effects on the children, which are substantial. So how does this look like in terms of how old the children are when the shock happens? So I will show you this here in terms of the welfare loss, but it's the same in all statistics. What we find is that younger children experience larger losses. So the largest losses are for children of age 6. So for them, the welfare loss is minus 0.71%. But for children who are age 14, when the schools are closed, the welfare loss is minus 0.41%. So why do younger children experience larger welfare losses? That has mostly to do with the self-productivity of human capital, and I will show that in a few slides from now. So children of age 4, they are actually somewhat sheltered from the negative effect of the lockdown of schools. So their welfare decreases by minus 0.48%. And this is the case because in their human capital production function, the weight on governmental investment is smaller. So for children who are not yet in school, parental investments are more important than governmental investment. So reduced governmental investment also has a smaller effect on these children. So the cohort that is hit the most by the school closures are the 6-year-olds, so the ones that are just starting out elementary school. So these are the effects on the children, already taking into account optimal responses by the parents. So how do the parental reactions to the lockdowns look like? So again, here I show you the average and then the change of parents whose children are of different ages when the school closures happen. And as you see, on average, in the period when the schools close, parents increase their monetary investment by 14%, the time investment by 7%, and once the children leave the household, the parents increase their inter vivos transfers to the children by 0.35%. So we see substantial reactions of the parents. So parents really try to counteract this negative effect of the school closures on their children. And these reactions of the parents, they do matter for the children. So if we don't allow the parents to react, so if parents would keep their investment unchanged after the school closures, then the welfare loss of the children would be 30% larger. So parents are successful in buffering the welfare loss of their children, but not fully so. Right? And obviously, this increased investment also comes with welfare losses for the parents. So how does the age profile look like here? It's a little bit more complicated because these are percent changes, but then I told you that especially in terms of time investment, we see that in absolute numbers, it's much larger for parents of younger children than for parents of older children. So if I translate that in absolute terms, then parents of young children increase their time investment in their inter vivo transfers by more, but their monetary investments by less than parents of older children. And the reason is just borrowing constraint of younger parents. So we have a borrowing constraint in the model. So parents of young children, they are young themselves, so they are more likely to be borrowing constrained. So they find it hard to increase the monetary investment right away in the period when the schools are closed. So they rather increase their time investment with the children or leave them higher inter vivos transfers, which they only have to pay out in the future and not in the period of the school closures. So here I show you now the money and time investment of one generation of children, namely for the generation of children who are age 6 when the school closures happen. So blue is the baseline data, you saw that already, and red is now the experiment, the data under the experiment. So this is the investment of money and time for these children for whom schools are closed at the age of 6. And as you see here, and as I showed you already in the previous table, in the period of the school closures, parents react substantially. So they increase their monetary investment by 15% and their time investment by 8%. But then in all future ages of the child, you see the red line is actually slightly below the blue line. So the parents reduce their investment into the children in future periods. Why is that? Well, that comes from this dynamic complementarity in the human capital production function. So the school closures lead to the effect that these children have lower human capital when they arrive at the age of 8 than they would have had in the absence of the school closures. And given this lower human capital, the optimal investment of the parents is also slightly decreased. So this is then how the human capital of these children evolve. Again, blue is the baseline, red is the experiment. So you see these lines diverging here, but it's very hard to pick it up because we see this huge increase of human capital over the entire childhood. So on the right graph here, I show you the difference between the blue and the red line here. So this is a change in the human capital due to the school closures. So school closures happen at age 6, and due to the school closures, this generation of children arrives at age 8 with 1% lower human capital than it would have had in the absence of school closures. So we have this immediate effect despite the increased parental investment. But now you see, as these children progress further through school, the human capital gap even opens up even more. So that by the age of 16, when they take the higher education decision, the human capital is around 2% lower than it would have been in the absence of the school closures. And this is really due to the self-productivity of human capital. So having an initial negative shock to human capital translates into even larger human capital differences as children still go through school, as they are still in this period in which they accumulate human capital. And if you think of it, it's kind of intuitive. So if children are young when they are hit by the school closures, that means that they might learn to read and write and do math less proficiently than they would have had if schools would have been fully open. And that has negative effects on their learning in all future periods. Right? And this is why this human capital gap opens up. While children who are already age 14, when the school closures happen, they also take a hit in their human capital. But then, since they are at the end of the human capital accumulation process, this doesn't have much consequences anymore for any future human capital development. The reduced parental investment in future periods also contributes a little bit to this opening of the gap, but it's really, really minor. It's really mostly due to the self-productivity. So here's the result of the welfare loss if we first only model the experiment of the lockdown of schools, or if we add to that the asymmetric income shock. And as you see, the welfare loss is basically unchanged. So for the welfare of the children, the income recession is almost irrelevant. So this is kind of surprising. Why is this the case? Well, it comes from the fact that the negative income shock comes with an increase of hours for the parents. So if the income shock hits, the parent uses additional time that they don't work anymore to invest into their children. Now, you might argue this is a little bit counterfactual because unemployed parents, they are under a lot of stress. They have to search for a new job. They have to write job applications. So it's not as if all this time that they don't work anymore is freely available. So even if we model the shock, though, as a pure income shock, so even if only the income decreases and the amount available to invest into children stays the same in terms of time, the welfare effects of the school closures still dominate for the children. And they will still make up to 80% of the total welfare loss. So from a children's perspective, the income recession of the parents is almost negligible. So what really has a negative effect on the welfare of the children are the school closures. So these are model implied effects, and to validate them, it would be nice to see whether they're in line with empirical evidence. And I'm sure that 5, 10, or 15 years from now, we will see papers that can actually, in the data, see what are the long-term losses of the children. So far, we can only look at relatively short-term outcomes. And here I want to stress that the increased time spent with the children during the closures in our model is 1.2 hours per child a day. And this is roughly in line with evidence by Adams-Russell and co-authors who conducted surveys in the US, in the UK, and also other countries and find similar time increases of the parents spent with the children. When it comes to the long-term earnings, I just want to mention again the paper by Hahn and Willen. They find long-term earnings losses of 2 to 3%. We find long-term earnings losses for children in elementary school age of slightly more than 1%. Due to 6 month school closures. So our estimates are around half the size of theirs. So they might be conservative, but obviously it's a different episode and a different country. So it's not that clear how comparable these episodes are. So last, let me discuss how our results look like in terms of distributional effects. And specifically, we are interested in 2 dimensions of heterogeneity. First, and most importantly, heterogeneity of the effect for parents that come from different parental households. And secondly, also we are interested in how much does the length of school closures matter for the welfare loss. And last, I will combine both dimensions. So let me start with heterogeneity by parental characteristics. So there are three basic characteristics by which parents differ: the marital status, the education, and the asset quintile. So here I give you the average welfare loss for children coming from single or married households, households with different educational status, and households from different asset quintiles. And as you see, along all three dimensions, we find around 30% larger welfare losses for children who come from the more disadvantaged household than for children who come from the most privileged households. So the welfare losses are around 30% larger for children with single parents, with lower educated parents, or with asset poor parents. And the reason for that is fairly straightforward. These parents from more disadvantaged backgrounds, they have fewer financial resources, they face borrowing constraint, so it's harder for them to counteract the school closure effect on the children and increase especially their monetary investment into the children. Now, 30% might not sound that large, but in reality, obviously, these parental characteristics are correlated. So through this correlation, the heterogeneity in the welfare effects becomes much larger. So I show you here the two most extreme group. So these are children from the most disadvantaged households, so single parents who are high school dropouts and belong to the lowest asset quintile. And these are the welfare losses for children for the most privileged households. So married parents who are college educated and belong to the highest asset quintile. And now you see that the welfare losses are around 4 times larger for the children from the most disadvantaged households than from the children from the most privileged household. So there's substantial heterogeneity in the welfare losses by parental characteristics. And actually, if you look at the full distribution of welfare losses, what you find is quite bimodal. So there's really a bunch of children who come from favorable backgrounds and for whom the welfare losses are relatively minor. But then there's also a very large group of children who come from households with less favorable characteristics and for whom the welfare losses are much more significant. A second dimension of heterogeneity that we're interested in is the length of school closures. So different school districts closed their schools for different amounts of time. So here I just show you one number. So the welfare loss of 6 months school closures is minus 0.55%. And the welfare loss of 1 year school closures is more than twice as large. It's minus 1.21%. So the effects are disproportionately increasing the longer the schools are closed. And this convexity arises again due to the self-productivity and the dynamic complementarity of human capital. So the longer the school closures are, the disproportionately more increase the welfare losses of the children. Now we model school closures as schools being closed, but we know that in reality, a lot of schooling was then replaced by online teaching. So Engel et al. Argue that this is not very effective, but I think the jury is still out there a bit. But what we are accumulating is a lot of evidence that there is substantial heterogeneity in the online schooling. And here I show you just one piece of evidence that comes from Opportunity Insights. And it shows you the percentage change in student participation in an online learning tool that is called Zearn. So it's a math online learning tool. I don't know if you have that in the UK as well. And so here they look only at students who used Zearn before the school closures. And this is March 2020 when the school closures happened. So initially, the usage of Zearn dropped for everyone. And these are students from high-income households, from middle-income households, or from low-income households. So initially, everyone's participation in the online learning school dropped. But then for the children from the high-income household, fairly soon afterwards, already before the summer vacation, participation was back at the old level. And by today, participation is even higher than it was prior to the crisis. While for children who are from middle income or from low income households, even today, the participation in this online learning tool is lower than it was before the crisis. So this is just one piece of evidence, but there are different papers collecting this evidence that kind of seems to show that first, online schooling is offered less often to children from disadvantaged households than conditional on having online teaching, these children are less likely to participate in it. And third, I even saw some evidence now that once schools open again, children from disadvantaged households are less likely to return to school. So they take longer until they return to actual physical teaching. So there is mounting evidence that there is a negative correlation between parental characteristics and length of effective school closures. So how strong this correlation really is, we don't know yet. But what we know is that this kind of correlation will substantially magnify the distributional effects of the shock. So here I show you one admittedly extreme example, where we assume 12 months of effective school closures for the most disadvantaged, for children from the most disadvantaged households, but only 3 months of effective school closures for children from the most privileged household, where I say effective here in order to also capture whether these children participated in online teaching or not. And now you see that the socioeconomic gradient becomes much steeper. Now we see even 18 times larger welfare losses for the children for the most disadvantaged households than from the most privileged household. And the welfare losses now for the children from the most disadvantaged households are really large. So they amount to minus 1.6% in terms of the consumption equivalent variation. Okay, so then let me conclude. What we find based on a structural model is that 6 months of school closures lead to substantial long-run losses for the children, namely to minus 1% of gross earnings over the entire working life. This sums up to minus 1.4% of the US pre-crisis GDP and is associated with a welfare loss of minus 0.55% in terms of the consumption equivalence variation. And we also document a substantial socioeconomic gradient in the welfare losses, and how large this gradient really is, I think, will depend a lot in what the evidence will be in participation in online teaching in the end. So let me end with a word of caution. Our paper is not a cost-benefit analysis. So most importantly, our model ignores any potential health benefits from the school closures. So we don't have an epidemiological model here, and so we also cannot do optimal policy and say, should schools be closed or not? I mean, if you read into this literature on what are the health effects of school closures, so I'm interested in it, so I read a little bit into it, and I would say the jury is still out there. There seem to be different evidence on that. But so we abstract completely from the health benefits, and we still think our paper is providing the service of giving one estimate of the economic cost of the school closures for the affected children, and policymakers can take that into account when they make the decision whether to close schools or not. But our model ignores not only the potential health benefit, it also ignores some cost beyond these economic costs that we are modeling. It ignores a loss of social contact or psychological stress for parents and children. And both these factors could also lead to lower accumulation of non-cognitive skills, which also have been shown to matter for earnings. And we also ignore any long-run fiscal or, even more importantly, growth consequences. So the lower human capital of the children could lead to lower growth in the future, which would affect earnings even more. So many thanks for listening.
Thank you, Nicola, for an absolutely fantastic talk that was super detailed around the model and still kind of got through everything, I think, in a really kind of clear way. There are a number of questions that have come in, but I wanted to start with one question about this assumption about monetary investments. Mm-hmm. Clearly, when you've got an aggregate demand shock, you can buy the monetary investments from somewhere else because they're generally things like tutors and stuff. But when you've got an aggregate supply shock in which everyone's locked into their houses, what kind of monetary investments are these people going to be making? You can't go out to the zoo, you can't go out to educational kind of establishments and spend money that way. I guess you could get home computers and other things like that. So kind of what are you thinking? Clearly in a pre-pandemic setting, these people can make a lot of monetary investments that they can't actually make when everyone's got a big aggregate supply shock?
No, you raise a very, very good point. So we allow monetary investments to be adjusted freely, while, as you point out, I mean, in the crisis, many things couldn't be easily purchased, and there were lots of restrictions. So we were debating that we were still thinking, let's have monetary investment adjust. And you were already pointing out a few things that could happen. You could hire online tutors, buy the equipment, so the computer that the children need, the printer. I mean, getting a better internet connection, or all these things. That said, we can shut down monetary investments, and as I already mentioned, if we don't allow for any parental investments, the welfare losses increase substantially, so they become 30% larger. So it does matter. We haven't done the decomposition, and that would be a good point to just say what happens if you don't allow monetary investments to adjust, but still time investment. And I guess we would be somewhere between the welfare loss that we estimate here and a 30% larger one.
Okay, thank you. And then there's a number of questions that I think kind of reflect your own kind of, some of your last slides where you looked at multiple aspects of parents. And I wondered, one of the questions was, could the model account for differences in parental employment that are orthogonal to income and education? For example, well-educated stay-at-home moms. How do you think that would affect your estimates?
So these differences in terms of employment, or then that results into time, endowment of time that can be spent with the children, before the crisis, they are partly taken into account, because we take the labor hours of married and single couples directly from the data, as well as the number of children. So we do have this effect that for married couples, per se, it's easier to buffer this shock first, because there are two individuals who can spend time with the children. And on top of that, because in the data, married couples, they work fewer than twice the hours of the singles. So we have some of this variation in there, and especially this difference between married and single parents comes exactly from this fact. So clearly, if you're a married couple, it's easier to arrange taking care of the children while the schools are closed than if you are a single mother or father.
Okay. And then I think there was a question that I suspect that would be rather difficult to answer, but was, could you analyze within schools to take up account of indices of multiple deprivation and wealth?
So differences within a school.
Yeah.
I mean, that's not really, I mean, it's a macro paper, so we take a much more macro perspective than looking within the schools. But I do think there are important lessons to be learned from the paper in terms of what could governments do, or what should governments concentrate on in order to counteract this shock. And I think that there are two important lessons. The first is if the governments want to help the children, they should do it fast. Right? Because we have this self-productivity of human capital, any measures to overcome this initial loss, the sooner they are taken, the better. So if the government can think of extra schooling, I don't know, maybe during the summer vacation or during the afternoons, hiring extra teachers or so, once the pandemic slows down, that would be very useful. But the second important lesson is clearly that the government facing limited resources should focus on the children that are from more disadvantaged households. So this is really the ones that suffer most, and for whom the additional governmental investment after the school closures would be especially important. And here I want to point out that this is not something in the model, but I mean, it's clear, I mean, and we captured a little bit with the exercise at the end. It's clear that online teaching is just less effective for students from more disadvantaged households. So they likely have a smartphone, but they are less likely to have a printer or a real computer, which makes it much easier to follow a video conference. We all know how hard this is on a smartphone, but also they just lack the space at home, the quiet space to sit and study. I mean, they lack a structured day. It's very hard to keep track of different online times if it's not every day at the same time. So I think the socioeconomic gradient, this is a really important message for us that matters a lot. So government should really try to help children from the more disadvantaged households.
Yeah. Well, I think it's lovely. It's so great that your model, in a sense, complements some of the micro stuff that we have by showing this investment function and the fact that you need to invest early and you need to invest soon to make up that gap. So I think, unfortunately, on that note, although I can see another question or two coming in, it is 18:15 and we are coming to the end. So I think it remains for me, Nicola, to thank you for a fantastic Hahn lecture and end to a really nice conference. And thank you very much for such a clear and inspiring presentation. I think both inspiring to the macro folk in the room and the micro folk who are listening. So thank you very much for that.
Thank you for the invitation. It's a pleasure.
A pleasure. And it remains for me to close this conference, which is very sad. It's been a great conference. I've attended some fantastic sessions. I hope you all have too. I first want to thank Nicola and the other keynotes for coming, to Matt and to Guido, and of course to our two past presidents. We've had not one, but two past presidents addresses in both Rachel and Nick, which I think has been fantastic. I'd like also at this point to thank Ricardo Rice, who's been a fantastic conference chair, and for creating this rich and interesting program, the lovely innovations of the lunchtime chats, which I think many of us have enjoyed. And also to thank very much the people in the background who've worked so hard to make this conference happen. Georgina Jenkins, Coralie Simmons, Mary-Louise de Menez, Leighton Chipperfield at the RES, and Michael McMahon as conference chair at the RES. It's been a really tough year, and I think we've done really well. So thank you again. Finally, I thank everybody. There were at one point 800 people who'd signed up for this conference. Thank you very much for attending and taking part, for contributing. And when you can't contribute in person, but adding to the chat and the Q&As and everything else. And that's just been really good. And finally, we look forward to welcoming everybody in 2022 and hopefully in person, and it will be in Warwick. So at that point, I'd like to say goodbye to everybody and thank you very much for attending.